Ya, bismillahirrahmanirrahim. Jadi kita tengok chapter yang ketiga lah, iaitu programming concept. Programming concept ni penting, is important to you guys to understand, because some of you are not from the IT background. This one is very vital to know lah. Okay, for programming concept, first of all, you need to know is about to define the paradigm and programming paradigm which will support the computational through the functions. This one I have explained in the past two slides before this. Then functional programming paradigm makes comparison as the evaluation and mathematical function and also expressions. This one also I have explained in slide week 1 and slide week 2 lah. Okay. For this week, we look deeper, more into a programming language, more specifically on a programming language. Okay, we look into the semantic, pragmatic, syntax, semantic and pragmatic. Okay. Okay, if you have any question, you can ask because this class is basically is a face-to-face class. For time being, I will explain in both language. Ada yang international student? Do we have international student here? Dah drop yang minggu lepas. Okay. As you can see, syntax in programming, is basically refer to the language that are defined to a structure of the language. As you can see in the figures, we have expression is true and expression is false due to the syntax. Syntax, it means that it also have a structure. Okay. And then syntax in computer programming also control the structure of symbol, punctuation, and also words of programming. This one we call as a code of the programming. Okay, and then without the syntax, the meaning of the semantic of the language is nearly impossible to be understood or understand. Okay, and then the syntax also known as the arrangement of the words. Arrangement of the words, sentences, clauses, and also phrases. Okay. And also the relationship between the components. For example, a series of English words such as a subject need and does sentence a verb has a little meaning without the syntax. Okay, while in the programming, it means the set of rules that define what the various combination of a symbol. For example, here we have do while expression, we have exit do, and then we also have a loop statement and so on. This one is very important to know. Okay, do you have any questions so far? Is it okay? Boleh continue ke?
Boleh, Doktor.
Boleh, Doktor.
Okay, this one is semantic. Okay, semantic in programming. Okay, semantic in programming is a rigorous mathematical study of the meaning of the programming language. Okay, meaning to say that semantic sometimes refer to the meaning of instruction, not focusing on the syntax. It also look closely on the mathematical proof lah. For example, here we have operational semantics. It define the result of execution and also for the abstract machines. For example, we have machine state configurations, control and data. Okay, for example, if a programmer write a function that compile or interpreted successfully but doesn't work, that will be a semantic error. Semantic mean that refer to the instruction error. Instruction error. Okay. And then semantic study also can be applied to entire text or a single word. For example, we have destination and we have last stop. That mean that destination and last stop is same thing, but student of semantic analyze the subtle shade of meaning. Okay, same goes to programming. If the programmer misspell a keyword or function name, and the program cannot be successfully compiled or interpreted based on their code, the compiler cannot be successfully compiled or interpreted, that will be a syntax error. This one is based on the semantics. Okay, what is the differences between semantic and syntax? As you can see, put in a simple way, semantic refer to syntax refer to the grammar, while semantic refer to the meaning. Okay, for example, syntax is the set of the rule needed to ensure the sentence is grammatically correct, but semantics is focusing on how the lesson or the command or the statement, grammatical structure, tones, and other element of sentence to communicate its meaning. For example, here we go by syntax. Syntax is refer to the meaning. Refer to the grammar. Grammar, which mean that refer to several code of instructions. While in semantics go on the how the grammatical structure will work. Okay, configuration. Configuration. Okay. Ada soalan ke?
Doktor, ada orang nak masuk.
Ada orang nak masuk? Siapa nak masuk?
Ada student lain nak masuk.
Ya. Biasa yang lambat saya tak bagi masuk kan. Siapa yang baru masuk tu? Daniel?
Saya kena minta maaf.
Kenapa?
Saya silap tengok, saya akan kelas tak pukul 10.
Kamu tak tengok WhatsApp lah. Tengoklah
Saya
WhatsApp.
tengok. Tak perasan.
Power kamu boleh tengok WhatsApp. Saya kamu kamu pinggirkan macam tu.
Tak adalah.
Kelas saya pun penting juga. Kelas lecturer lain penting. Kelas saya pun penting juga. Jangan anggap kelas saya ni kelas main-main. Kelas saya ni critical sebab dia ada daripada kamu yang tak pernah ambil programming. Sebab itu saya kena fahamkan kamu lah. Lagi siapa? Anissa. Siapa yang baru masuk tadi? Anissa? Ke dah lama masuk?
Saya je.
Siapa tu?
Danish.
Yeah. Kenapa baru masuk?
Ada kelas saya doktor 8 sampai 10 je sebenarnya.
Ya ke?
Ya.
Apa nama? Danish. Danish Isyad. Danish Iyad.
Danish, yes. Ya.
Lagi seorang lagi? Siapa tadi?
Saya doktor. Saya pun ada kelas 8 hingga 10.
Siapa? Yelah, nama siapa?
Kuganastri.
Kan tak ada tadi kan kamu dah WhatsApp saya.
Ya doktor.
Lagi? Yang minta maaf tadi tu siapa?
Saya doktor Nur Anissa.
Anissa. Okey, sekejap Jadi kalau ada kelas maklumkan kat saya lah. Saya pun tak maklum kamu punya jadual macam mana Jadi kena ni lah. Anissa mana nama kamu ni? Tak ada pun. Anissa ada.
Saya pun Doktor, Alif
Ah.
Najmi.
Alif Najmi, kenapa? Lambat?
Tadi saya ada kelas juga sampai pukul 10.
Ya ke? Tak percayalah kamu.
Betul Doktor.
Kamu budak awesome nipu lecturer ni.
Tak kot.
Alif Najmi. Tak ada pun nama kamu. Ada. Yang kali maklum dekat grup Grup tu umpama kamu punya komunikasi lah. Jangan miscommunication. Okay dah. Saya teruskan Boleh ke?
Boleh Doktor.
Boleh Doktor.
Okay, we continue this one. Okay, we go by the pragmatic programming. Pragmatic programming in that term refer to the best practices. So you have semantic, you have syntax. This one is best practices. Refer to writing clean code and managing the code in the manner of efficient. To ensure the code is understandable and be keep in readability. Mean that it easy to understand. Okay. And then for the it also writes the code by the people that will read the code in the future, which means that it from the people to the people. Okay. Okay, for the pragmatic, they also have the pragmatic programmer, which qualifies some of the programmer to be fast adaptation and also critical thinking. Fun for the pragmatics. Okay. Okay. If you can see, pragmatic, we versus the syntax. Okay, syntax is what to do is to communicate on the most basic level. Semantics help us to determine if there are any meanings to the code. And while pragmatic enable us to apply the correct meaning to the correct situations. Okay, pragmatic. Okay, this one is a higher level. Okay, we have syntax. We have what else? Semantics, and this one is pragmatic. Pragmatic is the enable us to apply the correct meaning to the correct situations. Okay, other meaning for pragmatic is the refer to a way on how language or programming is practically being used or being practiced. Okay, we have lexeme. Lexeme is the lowest level of syntactic unit of the language. Okay, basically it can be a single word or string or a words. Okay, each lexeme is categorized by the name or a token. Okay, for example, we have here token constant, lexeme also constant, and we have pattern. Pattern also constant. But if a token is relation, lexeme is the numerical, literal, operator, special word, and others. You can see the relation here. It represented by the special character. And then we have pattern. Also, if you see token is literal, and then lexeme is the hello world. It is different. Is lowest level of syntactic unit of a language. Okay. Okay, for example here, you can see input, lexical analyzer and a syntax analyzer lah. This one input, the compiler need to read the characters, and then token to syntax analyzer, and then syntax analyzer will give and ask for the token and push back some of the special or extra characters lah. Okay, another example we have left parenthesis. Okay, left parenthesis is open bracket. For the token is we name it as a left parenthesis. If the lexeme we just look on the keyboard is the open bracket lah. Pernah tengok ke open bracket? Tahu ke open bracket ni macam mana? Kat kamu punya keyboard tu yang nombor 9 tu it is open bracket and 0 is a close bracket lah. Boleh ke?
Boleh.
Boleh doktor.
Jika kamu kata kelas Dr. Hafizah tak faham pula, ni saya terangkan step by step lah. Okay, recognizer and generators Language recognizer and language generator are two formal approach to describe the syntax. Okay, we need to construct a recognition device called R to capable of reading the characters of the string from the language L. Okay, and then R will examine whether the given string is in the language L, and R is either will accept or reject the given string. Okay, and then R acts as mechanism of filtering and separating the legal string from the language L. Okay, and then we have recognition device. We call it as R. R for what? R for roti. Okay, R for roti is a recognition device in language L. Okay, given a string, a recognizer. Okay, recognizer is called R. For a language L, tell whether a string is in L. Example, a compiler. And then we have a generator for L will produce arbitrary string on L on demand. On demand, basically we have demand. Example, we have L is do, while, for, if, else, and so on. Okay. Okay, BNF stand for backers no form. Back us now form. NAURFORM. Back us BACKUSNAUR form lah. BNF. The term BNF and grammar are used interchangeably lah. Okay. Basically when you go by BNF is Jack Backers and Peter now revise, develop and formalize the syntax descriptions lah, which is later become the most popular method for programming language syntax, which is known as BNF. Okay, and then recognition and generation are useful for different things but are closely related. Okay, you can see here for defining the languages we have recognizer. Oh, siapa yang bawa masuk ni? Ada yang bawa masuk ke? Ke tak nak masuk dah? Sekejap saya check yang bawa masuk. Okay, Siti Sarah, kenapa bawa masuk? Oh, Siti Sarah.
Hello doktor.
Kenapa?
Saya cari line yang bagus.
Alasan lah kamu ni. Takkanlah tak ada line yang bagus. Belilah tiga
Ini
line.
lancar. Sebab
DG
kita
ada.
buka kamera kan.
Ya ke? Kamu tak buka kamera pun?
Okey.
Sama je like juga.
Saya mau habis kelas.
Sama je like juga. Lain kali masuklah awal sebab kelas saya ni kelas yang berbelik-belik sikit lah. Ramai student komplain kata tak faham lah apa dah. Padahal saya dah sediakan nota dah. Sekejap lagi saya sediakan recording. Dah. Okay, kita teruskan Okay, we have defining languages. We have recognizer and then we have generator lah. Okay, recognizer device read the input string of the alphabet of language and decide whether the input string belongs to the language. Okay, this one a part of compiler. For example, like I said before, is a recognition device. We call it as R. R for roti. And then we have generator, a device that generates sentences of a language. Can determine if the syntax particular sentence is syntactically correct by comparing to the structure of the generator. One we have language L. Example we have L language is do, while, for, if, else, switch, case, break, and continue. Okay, the recognition device that we call as R will not accept any reject any string such as repeat, near, stop, or go to, because all of these strings are not listed in the language L data dictionary, which means that it will recognize in the data dictionary. Okay, and then we have classification of grammar. This one basically using to define or to describe the syntax of programming language. In the middle of 1950, Noam Chomsky, the researcher, described 4 classes of grammar as follows. We have first type 0 grammar, and then we have type 1 grammar, type 2 grammar, and type 3 grammar. Type 0 grammar is unrestricted grammar recognized by Turing machine. Type 1 is context-sensitive grammar accepted by linear bound automata (LBA). Type 2 is context-free grammar accepted by push-down automata. And then type 3 is regular grammar accepted by finite automata. Okay. Later I explain. Okay, type 0 unrestricted grammar. Type 0 grammar is unrestricted grammar, is phrase structured recursively. Enumerable language and general grammar. Unrestricted grammar permit production of A implies B. A implies B. Whereby the A is the string of the terminal and non-terminal, which at least non-one terminal and cannot be null. A implies B. Alpha. This one. Grammar production of form A implies B. Alpha implies beta. Whereby alpha is V plus T multiplied by V, and V plus T V stand for variable, T stand for terminal. Beta is V plus T. Okay, type 0 grammar also language are recognized by Turing machine. These language are known as recursively enumerable languages. Okay, the other example is SA implies BA, A implies X, so on. Okay, one is depend on the rule given. Okay, the rule given in the programming language. Okay, and then we see the type 1. Type 1 is context-sensitive grammar. Requires the right side of the production rules has no fewer symbols than the left side. Okay, this one generate the context-sensitive languages. The language generated by the grammar is recognized by the linear bound automata. For example, this one, type 1 is A implies B, okay, which means that requires the right side of the production has fewer rule or fewer symbols. Okay. For example, this one right hand side AB. Okay, and then we have AB implies ABC. Okay, this one right hand side has a fewer symbol than the left side. Okay. A less than B. Okay, which means that the rule production rule has fewer symbols. Okay, and then we go by the context free grammar type 2. Type 2. Type 2 is required single non-terminal and on the left hand side alpha of production rules and the right side beta is combination of non-terminal and. Okay. The condition for type 2 is first it should be type 1, and then the left hand side production can only have one variable and there is no restriction on. And then the context free language are the theoretical basis for the syntax most programming languages. For example, we have alpha equal to 1 as implies AB, A implies A small cap, and B implies B small cap. Okay. Okay, this one is add on from the type 1. Okay, we have also left hand side production can only have one variable. Okay, and then we have type 3 grammar. Requires rule is restricted on the one terminal and non-terminal on the right side of the rules. There are two forms. Okay, two forms, namely as the left regular grammar here and right regular grammar. Okay. Okay. The type 3 is the most restricted form of the grammar. Okay, the type 3 should be in the given form only. V implies VT or V implies TV or T, right regular or left regular. Other than that, it will not be accepted. Okay, this one is grammar for the some of the linear push down and finite automata. Okay, classification of grammar. Okay, and then we look, okay, this one is example. Okay, and then we have meta language is encourage functional programming and often considered as impure functional language. As you can see here, we have meta language and meta thought. And then object language, we have law of identity. Basically, the definition is called rule of productions. Okay, example, we have assign. Then we have variable and expressions. The sign here is I left out some of the bracket, close bracket. Okay. Kamu betulkan sendiri boleh ke? Betulkan sendiri kat ni. Okay, boleh ke? Ada soalan ke? Ada soalan ke setakat ni?
Tak ada.
Boleh faham ke? Ini untuk apa? Untuk programming secara low level language. Jadi kita akan tengok ya.
Doktor boleh ulang yang betulkan yang mana tadi tak?
Yang mana? Siapa tu? Yang ni assign ni. Kan ada left ni bracket, assign ni saya lupa nak tutup.
Oh, okay.
Okay, and then we have attribute grammar AG. Attributed or we call it as attribute grammar, a word or a phrase that syntactically subordinate to others and serve as to limit the identify and particularize, describe, supplement the meaning. For example, here we have attributed meta model and attributed grammar. Attributed meta model, we have a model that attributed in instant. For example, we have a UML diagram here. We have attributed definition for every diagram that we seen. While the attribute grammar is we have non-terminal and terminals, and then we have attribute definition is different based on the subordinate. Okay, attributed definition for meta model. Meta model is as you can see is based on the graph or based on the flow. And then while the context-free grammar is based on the terminals and non-terminals. Okay, and then it also have the layers, instant layer. This one, as we can see, we have model and syntax-free. Syntax-free. This one is to describe, to limit, to identify, to supplement the meanings of the construction. For example, in the red house, red is an attribute of the house lah. We supplement the meaning. We add some meaning. Okay, and then for the abstraction, we have attribute grammar, non-terminal and terminals. Non-terminals, lexeme and token of the rule are terminals. Token of rule, we name it as terminals. Okay. Okay, and then to describe the semantics, semantics explain the meaning of the syntax, programming or grammar lah. Okay. And then grammar is a generative device for defining the language. They have two forms of categories. We have static and dynamic. Syntax the form or structure, while semantic the meaning, like I said in the early slide lah. Okay, language, syntax and semantic provide a language definitions lah. As you can see here in the figures, describe syntax and semantic. We have semantic, the general problem of describing the syntax, and then we have attribute grammars, formal method of describing syntax. Okay, some of the approach that we look into is a formal method to describing the syntax, the meaning. The meaning. Okay, two categories, syntax and dynamic. Okay, this one is static semantic. Okay. Static semantic is basically rule enforced by compiler at a compile time. Okay. They are implemented in semantic analysis phase of the compiler. Context-free grammar are not powerful enough to describe a certain rules. Okay. Example, we have type checking such as identifier used in appropriate context and checking the subroutine or function with appropriate argument and label submitted accordingly. This one is for static semantics. Okay. We can see here attribute grammars, dynamic semantic, operational, axiomatic, and denotational semantics. This one is the subordinates, okay, or the modular of the static and dynamic. Okay, and then we have dynamic semantics. Rules are enforced by compiler by generating codes to perform the checks and can be done at a runtime lah. Okay, as you can see, this one type soundness. Soundness mean that can be inferred as logical steps. Okay, what is soundness? Okay, if you learn formal method, soundness mean in logic, mean deductive reasoning. Argument is we call it as a sound if it is both valid in the form and its premises are true. Both are true. True versus true is equal to true. Okay, soundness has related meaning in mathematical logic, wherein a formal system of logic is sound if and only if IFF every well-formed formula WFF that can be proven in system is logically valid and respect to the logical semantic of the system. Okay, type of soundness we have static and dynamic, which mean that we have binding operations. Okay, another example, when the pointer are not dereferences unless pointing to a valid subject, and this is due to variable use but not being initialized properly. Okay, example of dynamic semantics error is array is out of bound, which means that the array subscript is beyond. We declare beyond of the subscript. For example, when you declare an array Array, for example, we have integer, small, subscript 10, and then you put the size beyond than 10. It will generate array is out of bound. This one is dynamic semantic. Okay, dynamic semantic that enforced by compiler to perform the check, and it can be done in runtime. Okay, the tools that we have here, we have IDEs, we have type checkers, language runtime, garbage collector, and proof assistant infrastructure. One is the tool to check the semantic specification, either be sound or not lah. Okay, boleh ke? Ada soalan ke dekat ni? Ke tak faham? Jadi kita nak check dulu we want to check first the logic of the basic structure of the programming. Kalau ada soalan boleh tanya lah. Ada yang baru masuk lagi? Siapa yang baru masuk tu? Ada yang baru masuk Okay, ada soalan ke setakat ni? Tak ada. Okay, saya teruskan Boleh saya teruskan?
Boleh.
Boleh doktor.
Boleh doktor.
Okay, habis dah. Okay, habis dah jadi nanti next week kita akan tengok identifiers, data type, type checking, binding and scope. After that, we are looking into object oriented programming punya structure. Jadi kita akan tengok next week